this diagram. Luckily, I don't have to take that quiz. This is CRISPR. So here's your. This will be on the quiz: clustered, regularly interspersed, short palindromic repeats. Which this is. I mean, so I'm a science geek, right? Yeah, ask my wife. How many books about science do I have? Right? Many, many, many. This is stunning science. It is the coolest thing that's come down the road in a long time, except for the really scary part of how it might be used. But anyway, it's really just something that was, discovered and elucidated in the last 10 years. And it is exploding in all of these different fields. So rather than freaking out about it, I just decided to think, wow, this is really cool science. And it is. It's just incredibly, some cases what I would describe as just incredibly elegant science, just amazing. We'll see how it influences agriculture. We'll see how it influences disease prevention and cures, all of those kinds of things. And I'm not in any way qualified to talk about those, so I'm not going to. This is, I've used this slide in class many times, but the gene editing in many cases is about turning on one or two genes or having them turn on at specific points in the development of the plant. And I include this just to indicate that this is something that nature does every day. These are, here's our other quiz, like, can you identify all of these by name? Of course, my class at Friedman, of course, can. I could not, because I couldn't for the life of me remember what the hell this is called. But these are actually all the same species. So you could actually cross these. And the difference between them is that genes are turned on and off at different times, right? And we did this by selection. We didn't do it by manipulating DNA. We just said, okay, I'm going to select for this trait. So it's that makes some people more comfortable with these new technologies because nature, quote unquote, actually does turn genes on and off, and in different ways depending on what you're looking at, or at different points in the life cycle. Hopefully I'm about done. I know, and it's getting warm in here and it's humid and yeah. We did make suggestions on regulation. So this is, like hard stop right there, and then here's my personal opinion. Although I think the committee actually agreed with this, the current regulatory structure is not prepared to deal with the new technologies. Period. The decision was made back decades ago in the US to not develop a separate regulatory structure for organisms that were genetically engineered. So they did it under an existing structure. And that worked for those early set of products that I talked about, but it's really difficult to see how they're going to work with something like CRISPR, a gene editing. And the suggestion we made is that you don't focus on the process, you focus on the novelty. And this is actually how they regulate these in Canada, is if it's this plant and you're talking about it doing something really, really different, then the government's going to review it. Rather than it's this plant and it's just this tiny bit different from all of the canola that you already grow, the government's not going to regulate it. We'll see how that goes, because that would require basically tipping over the apple cart, so to speak, of current regulatory structure and then building a new cart, which is a long and very tedious process. This is something, and I'll make this as my own personal point also. I've been at plenty of fora like this where the topic is genetic engineering, and I'm trying to avoid doing this to all of you, which is somebody stands up and says, I'm going to give you an hour worth of data, and if you want 20 more hours, I'll give it to you, and then that will certainly convince you that this is all fine, or it'll convince you that it's all terrible. This is not just about data. This is about, what do people value? What do they believe? Who do they believe? All of those kinds of things. Rather than just, if you want 1 million pages of data, I can give it to you. That's not going to shift people very far. In fact, it hardens people's positions. If those data contrast what you already think, in many cases it just says, no, I'm absolutely certain that what I believe is right. So We learned that. We have a number of people come in and talk to us about that. And the context varies a lot depending literally on where you are, what's the capacity of farmers, what's the understanding of consumers, et cetera, et cetera. Certain things, science is going. It's as a scientist, you know, part of me does kind of think, well, that's really cool. Certainly this is true. We can't like put all GE crops in one bucket and either say they're all good or they're all bad. They're in fact all different. And that the regulatory structures, and I'm speaking specifically about the US here, we need to take a serious look at that as we go forward. And then the uncertainties, we don't know what that would look like. What would consumers think of not only individual traits, but maybe categories of traits going forward? And then there is scientific uncertainty, which even as a scientist, I have to appreciate. Again, it's really hard to prove a positive. It's much easier to prove a negative. So again, having scads and scads of data is not necessarily what's going to convince everybody that they should shift their own interpretation of what genetic engineering should be in our food system. That little symbol probably means that yes, it does. It is that I'm done talking to all of you. Well, no, that's not true. I'm done talking at all of you, and now I will talk with you. So questions, comments. A very common kind of theme is we need genetic engineering to feed the 9 billion, right? To feed the population that we expect in 2050 or 2060. And that's, as you pointed out, the evidence that we looked at, unless you were very specific about what the circumstance was, is that in the United States, we have been incredibly effective at increasing the yield of certain crops over decades, starting with some crops like corn in the mid-1930s, and it's just a straight line. And we're going to continue to be good at it. And when you look at the trend over 50 or 60 years, if genetic engineering was the big deal breaker, then that line should go from this to this, right? It should become steeper. We're gaining faster. We're from year to year to year. And that, for at least the crops that are grown over a very wide acreage, which in this country would be corn, soy, cotton, and maybe canola. If you added those together, it'd be something around 160 million acres. That doesn't appear to be the case. And that's one where there was a lot of reaction to that, both from some companies, but even some of our scientific colleagues that said, and there's a bit, I think this is the right word, a tautology. Is that anybody, can you spell it? And then can you tell me what it is? But anyway, and it goes something like this. No, it has to increase yield because we know that it increases yield, right? That's a tautology. In fact, we don't know that it increases yield. So we didn't find much evidence except in those circumstances where if you looked at it at the kind of farmer level management, that using the genetically engineered crop was actually improving their management. They did a better job of controlling insects. They did a better job of controlling weeds. But in the US, farmers were already really good at that. Sometimes they were using pesticides. Sometimes they were using other strategies. But you know, when you walk through cornfields in the 1980s, right? They don't have weeds in them, right? So they were already doing it. And what it did was, this is why I made the comment at the beginning that I see a lot of it as being incremental. It just went from they're doing A to control their weeds, and now they're doing B, and there's no weeds in either one, but B is easier, or it's cheaper. That's the gain for the farmer. But the idea that it is broadly increasing crop yields to help feed the 9 billion, we didn't find that. And it was like immediate. We started getting comments. It's like the morning that the report was released. So we got, thankfully we got comments from, all sides. It's like, what do they call it? Circular firing squad, right? Yeah, it's crazy. But I'm pretty thick-skinned about that. So, and I'm an agronomist, so things like crop yield are the center of what I have done over the last 35 years. And it's Like, people don't have to agree with me. It's fine. This goes back to one of my closing comments that not all GE crops are the same. So some of them are now producing a compound that they weren't producing before. So this is like the BT corn that kills insects, or BT cotton. And that BT in that corn or cotton is actually classified as a pesticide. It also has, essentially no toxicity to mammals. It's very specific to insects. Some of the others, though, like Roundup. So Roundup was very widely used prior to 1996 and 97. It was maybe number 2 or 3 on the list. And now, of course, it's number 1. So if we were getting exposed to it, it was already in the food supply at that point. But most of them are not, something like Roundup it's a weed control measure, and it's closely linked to genetic engineering because we made the crop tolerate that particular chemical. But the crop is really, and we operate under this in the US, and this is, bureaucrat speak here, what's called substantial equivalence. Do we think that the corn that has that trait and the corn that doesn't have that trait, are they basically the same? And that's how we've treated it. It's not producing something new. It's producing something in a slightly different pathway versus a crop that is actually producing a pesticide, which is what the BT crops do. But it's a category of proteins that are very specific to be toxic to insects. So it does, one of the points I make in all discussions of this in the classroom and with farmers and all of that is you need to look at these on, fairly specifically, because they're not all the same, even in terms of our exposure, right? Because, if we're talking about corn and soy and things like that, I forget what the number is in terms of how much of the US corn acreage is actually consumed directly by humans, but I think it's less than 5%. It's very small. We use corn for 1,000 different things, but we don't eat that much of it in, whether it's sweet corn or tortillas or whatever. It's actually pretty small. I mean, I think there's a broader issue there that is not unique to genetic engineering. It's the broader issue around pesticides and the impact of pesticides on organisms that actually are not our target. So what we might call beneficial insects or pollinators in the environment. And that's something that we did talk about as a committee, but it also is this question of which risks are unique to genetically engineered crops and which are really risks that we need to think about in our agricultural system in general. And the one that you raise is actually that latter part. It is, there are lots of things going on that influence wild insect populations, birds, mammals, microbes, all of those things. But that's been true since we began agriculture, essentially. And we did need, eventually we had to draw a boundary about what are we going to focus on and what are we not. And it really came down to, could we talk about unique benefits and unique risks rather than risks that are inherent in the way that we run agriculture in this country and elsewhere. So I hope it doesn't sound like I'm trying to sidestep that, but the specific question that you ask is really, when I hear that, is really about the broader use of a bunch of chemicals, a few of which are tied to genetic engineering, but most of which are not. They're chemicals we've used for 10 years or we've used for 50 or 75 years to solve certain problems, pest-related problems in agriculture. Yeah, the question is, are there now more pesticides in the environment than there was pre-1997, let's say? Fair question? Okay. It's either flat or declining. It's not, yes. Yeah. Yep. No, not necessarily. I mean, integrated pest management. It's, which we had before 1997. And that is just a strategy of how do we collect certain kinds of information so that we could we could release beneficial insects, or we could use this pesticide. But we do it only when we know that there is a problem that justifies doing it. Prior to that, you could get on it what they called calendar sprays. Like every 3 days, you just go spray. You don't even know if there's a pest out there. So there's lots of things that have at least in this country, have stabilized the kind of release of pesticides into the environment. And you also have shifts in which pesticides are being used. So not so much things that kill weeds, but things that kill insects. The early insecticides, many of them are neurotoxins developed in wartime, et cetera, and there's been kind of a evolution where the industry, and for good reason, has tried to replace those with things that are not as harmful to humans or other organisms. So if we just talk about like how many millions of pounds are out there, it needs to be a little bit more nuanced than that, because not every pound of pesticide is equal. Some are, orders of magnitude more or less toxic than others. And I wish there was like a really handy index almost that would help us, and we looked. And there are articles out here that establish an index like that. Most of them not very useful. But in the U.S., the total amount and also the amount per acre of production is stable. It might be up a little bit in some crops, but in others, I breezed over a graph that was on insecticides on cotton. It's probably reduced insecticide use on cotton by 80% in the United States, and likewise in China and India and places like that, because they're using Bt cotton. Yes, one of my classes that met yesterday, our entire class period was an exercise around neonicotinoids, and that came up repeatedly in our conversations in the committee. However, we didn't address those because none of that is genetic engineering. That is a pesticide that's being, usually they coat it on the seed, and then when the plant grows, it actually takes it up. And there is, certainly they've taken more actions in the European Union than we have taken here, but it is very definitely a topic of interest here, not just in general, the fact that you asked the question, but at EPA, because of the other impacts of the use of that pesticide. It's very effective in an agricultural sense, but the big concern and the big uncertainty is how much of especially the impact on pollinators is due to that versus other factors. And it's not a on-off switch. There are many factors that influence pollinators, including our agricultural landscapes are very simple. They're not complex. They're not really intertwined in the way that they would be if agriculture wasn't there. So, but great question. But I wouldn't say we ignored it, but it was outside of what our eventual boundary was, because it really is not connected to GE in any way. It's a pesticide issue. Some of the sub-Saharan African countries, some of the European countries, but it depends a little bit on which product it is, that they won't import it. And I'm not an expert on trade, but it's certainly not. I mean, some countries won't allow the import of it, and then obviously there's a whole set of countries that will not allow the use of it in their agriculture. For a long time, the European Union, you could make that as a blanket statement that they didn't allow GE crops, and that's not true anymore. They're using some GE crops to produce things like crops that they know that are only going to end up as feed for cattle or pigs or chickens, but not directly consumed by humans. And those are governance issues. And we explored governance, not only in the US, but globally. And to a very limited extent, some of the trade issues that are around that. And